Unique property number 3, water is less dense as a solid. Now with most chemicals, as they get close to the freezing point, the molecules will actually pull closer together, so it becomes denser and denser. Water, though, is very unique, and this again relates to its ability to hydrogen bond. When it gets between 1 and 0 Celsius, getting really close to that freezing point, the molecules actually begin to push each other apart a little bit. They won't get any closer than that hydrogen bond allows them to. So they push each other apart a little bit, and that makes ice less dense than liquid water. Now, what does that mean? Well, that means that if you put some ice on some liquid water, it will float because the ice is less dense. This property is important to living things for a couple of different reasons. For one thing, solid water being less dense than liquid water means that ice will actually float on top of a lake instead of sinking. If the opposite were true, then every time the ice were to freeze in the cold season, it would sink to the bottom of the lake, for instance, and it would sit there in a layer, and it wouldn't melt during the summer. The next year, when it got cold again, more ice would form. It would make a second layer, and it would just sit down there. The next year, it would freeze again, more ice would form. So these freshwater sources would freeze from the bottom up. The presence of ice is also important as an insulator. Now you might have felt sorry for fish living under the ice in the wintertime, but actually that ice is protecting them. It's ensuring that that water under the ice stays just above freezing, whereas the air above the ice might get even colder than freezing, and it allows those organisms to live down there. There are certain ecosystems that are formed because of ice. For instance, the giant ice sheets where polar bears are known to hunt during the winter months. Now we're going to talk about pH more in the second part of this chapter and also in Lab 3. But for now, you need to know that the pH scale is actually based on water, and that water has a pH of 7. Pure water is neutral. It's neither an acid nor a base, and so it has a pH of 7. The next couple of unique properties have to do with the heat and the temperature of water, so I want you to understand these concepts well before we move on. Although we use the words heat and temperature synonymously in everyday language, they're actually not the same thing. Heat is a measurement of the total energy of molecular motion within a substance. So the total amount of movement of kinetic energy in this collection of water would be the amount of heat energy that this collection of water has. Now this is different than temperature. Temperature is actually the average energy of motion in this collection of water. So what's the difference? Well, let's say we added some heat energy, some kinetic energy to this little molecule here. It's going to start moving faster, so its heat is going to go up. However, if we compare that amount of heat that we pumped in to the average of all of these molecules, the average isn't going to increase very much just because we added a little heat to that one molecule. However, if we begin to add enough heat energy and several of these molecules begin to absorb it, then eventually the average amount of kinetic energy in this little population of molecules is going to increase. And so in that case, the temperature would begin to rise. Conversely, if we remove heat from enough of these molecules, the temperature will go down. So heat and temperature are related to one another, but they're calculated differently, and they represent two different things. We even measure them in different units. Heat, for instance, is measured in things such as calories and joules, whereas temperature can be measured in Kelvin, Celsius, or Fahrenheit. To illustrate this concept, I'd like you to consider the water in these two beakers. Both beakers contain water, although they contain different amounts. This one contains 50 mils, whereas this one contains 100 mils. Both of these beakers have the same temperature, 100 degrees Celsius. However, How do you think the amount of heat in these beakers compares to one another? Think about it for a second, and then we'll discuss it. So hopefully you took a few moments to consider this scenario. Again, we have two beakers with different amounts of water that happen to have the same temperature. How does the amount of heat energy compare between these two beakers? Well, the amount of heat energy in these two samples of water is going to differ quite a bit. This beaker has less water, so it takes less heat energy to get it up to 100 degrees Celsius than in this beaker. It actually takes twice as much heat energy to heat the larger sample of water up to the same temperature. So the heat in the beaker on the right is quite a bit more than the beaker on the left. Even though the temperatures are the same, the amounts of heat differ. You've probably experienced this if you've heated things up on the stove before. You know that if you have a container with just a little bit of water in it, you can heat it up, increase its temperature, even heat it to the boiling point a lot faster than if you have a really big container of water. You have to pump a lot more heat energy into a large volume of water to bring it up to that same temperature. Different chemicals have different heat capacities. The heat capacity is the amount of heat energy a substance has to absorb before the temperature of that substance will increase. Chemicals such as alcohol have a pretty low heat capacity. That means that they don't have to absorb very much heat energy before the temperature goes up. How does this compare to water? The fifth unique property of water is its high heat capacity. Now, you've probably experienced the heat capacity of water, maybe in the wintertime. I certainly did the first year I moved to Austin. First year I moved to Austin, I noticed that bathing suits were for sale all year round here, which is kind of unique. So I thought, well, hey, the air is warm outside, let's go for a swim. So my husband and I went over to the apartment pool and jumped in, and it felt basically like this. That water was freezing. So why is it that the water's so cold if the air is in the 90s and hot? Well, it's because of water's high heat capacity. You have to add a lot of heat energy to water to get its temperature to change. Conversely, you have to take a lot of heat out of water to get it to cool off. So that water was cold, and it was still cold after the winter months, and it takes a long time for it to absorb enough heat from the air to be nice to swim in. Now, this property is really important environmentally to many different ecosystems. It allows water to sort of absorb heat during the day and sort of release it at night. And so that keeps the temperature of ecosystems near water sources a little bit more stable. Here you can see a demonstration of the high heat capacity of water and its effect on certain ecosystems. Here we have the coast of California. And what you can see here is that the temperatures taken at this time along the coast are cooler than those taken inland. Now, why is this? What's the water doing? Well, the water has to absorb a lot more heat than the air before it heats up. So the areas closest to the water are remaining cooler than those inland. Rock, soil, and air have a lower specific heat, so they can change really rapidly. This is also important because it means that the temperature of our bodies isn't going to change rapidly because the temperature of the water in our bodies is going to remain pretty stable. Property number 6 relates a lot to property number 5, the high heat capacity. Um, Water has a very high heat of vaporization. And what that means is that you have to add a lot of heat energy to it to get it to evaporate, to go from a liquid to a gas. Conversely, you have to take a lot of heat energy out to get it to go from a gas to a liquid or a liquid to a solid. This is what allows the water cycle that you learned about in elementary school to work. It also allows for evaporative cooling. When you sweat, the water in the sweat is going to absorb a lot of heat energy before it evaporates. And when it evaporates, it will carry all that heat energy away from your body. So that's the reason that sweat cools you off. This also helps prevent cells and ecosystems from losing too much water due to evaporation. It means that if we turn the temperature in the room up a couple degrees, you're not going to lose all your water to evaporation and dehydrate and die. Property number 7 has to do with the reactivity of water. Now we think of water as being kind of mundane, kind of boring, that it's non-reactive, right? It's kind of a background chemical, but it actually plays a part in a lot of important chemical reactions. Now just to remind you, in case you've forgotten, this side of this chemical equation is called the reactants. Those are like the ingredients going in. And this side of the equation represents the products. That's what comes out of the reaction. In general, the arrow will point towards the products. What you can see in this reaction is that water is both a reactant and a product in this reaction, and it happens to be photosynthesis. Unique property number 8 has to do with the compression of water. Because of the hydrogen bonding between the molecules, water molecules are already as close together as they want to be. So if you put pressure on them, you're not going to be able to crunch them any closer together. Now that provides kind of a good stable platform to build a cell or a body around, and it makes water sort of more reliable. Now it is possible to compress water, but you would essentially need the forces found in the center of the sun, that kind of a thing. So water does not compress very well. Here's a your turn for you to complete in your notes. Here we have a concept map. On this concept map, there are 8 water droplets. And what I want you to do is to summarize the 8 properties of water, one on each water droplet. So try to summarize it in 1, 2, 3 words maybe, keep it maybe a really short phrase, and then write that over those 8 droplets. It seems silly, but it may help you remember it a little bit better. Just a little more reinforcement. In this your turn, I want you to look at these pictures and tell me which property or properties of water each represents, and write it on there. A couple of these pictures may represent more than one of water's properties. Also, you should know that water's inability to compress is not on here, so that one won't be represented in these pictures.